A current loop having two circular arcs joined by two radial lines is shown in the figure. It carries a current of 10 amperes. The magnetic field at point O will be close to. According to the Biot-Savart's law, in a current carrying element, magnetic field due to an element dl at a distance r, which makes an angle theta with the element dl, is given by dB equals to mu naught upon 4 pi into idl sin theta divided by r square. We will apply this law to find magnetic field at point O due to this current carrying arc. Let us take an element dl at an angle phi . This element has the angle d phi. Current in this element will be in this direction, which is the tangent to the radius at this point. So the magnetic field due to this element dl at point O will be given by mu naught upon 4 pi into idl sin 90 degrees divided by r square, which will be mu naught I dl upon 4 pi r square. This dl can be written as r into d phi. Putting this value of dl in dB, we get dB equals to mu naught I into r d phi upon 4 pi r square. The total magnetic field due to this arc at point O will be integral of this dB from 0 to theta. So integral of dB from 0 to theta equals to integral of mu naught I upon 4 pi r into d phi from 0 to theta. This will be mu naught I upon 4 pi r integral of d phi from 0 to theta. So the magnetic field due to this arc at point O comes out to be mu naught I theta divided by 4 pi r. We will use this value of magnetic field to solve this question. So in this given question, R1 is 3 centimeters and R2 is 5 centimeters. The current in the loop is given to be 10 amperes. Now the magnetic field due to the segments PQ and RS at point O will be 0. As for PQ and RS, theta equals to 0 degrees. So the magnetic field due to PQ and RS will be 0. So magnetic field at O will be only due to the loops QR and PS, which will be given by mu naught I into theta upon 4 pi R1 minus mu naught I theta upon 4 pi R2, where this first term is the magnetic field due to the segment QR and the second term is the magnetic field due to segment PS. There is a negative sign between these two as the direction of currents in both the loops is opposite. This will become mu naught I theta upon 4 pi into 1 upon r1 minus 1 upon r2. And the direction of this magnetic field will be k cap. We can see this by right hand thumb rule. Putting all the values, we get 4 pi into 10 to the power minus 7 divided by 4 pi into 10 into pi by 4 multiplied by 1 by 3 minus 1 by 5 into 10 to the power 2. This will become pi by 4 into 10 to the power minus 4 into 2 by 15, which is 3.14 into 10 to the power minus 4 divided by 30. We can approximately write this 3.14 as 3. By writing so, we get 3 into 10 to the power minus 4 divided by 30, which will be 1.0 into 10 to the power minus 5 Teslas. So the answer is option D.